Welcome back to episode 2 of our series, IT from Zero to Software Engineer. In the last video, we covered the basics of what information technology is. Today, we're diving much deeper to answer a fundamental question. How does a computer actually work? It might seem like magic right now, but by the end of this video, you'll understand the core principles that make it all happen. Let's demystify the machine. First things first, what exactly is a computer? At its heart, a computer is an electronic machine designed to do three things: accept input, process data, and produce output. Think of it as a cycle. Input leads to process, which leads to output. This simple three-step loop is the foundation of everything a computer does. Whether you're browsing the web, editing a document, or playing the latest video game, it all comes down to this fundamental input-process-output cycle. It's the universal rule that governs all computing. Once you grasp this concept, everything else starts to click into place. So let's break down the components that make this cycle possible, starting with the physical parts. Let's talk about hardware. Hardware refers to all the physical components of a computer, the parts you can actually see and touch. Imagine building a human body. You'd need a brain, a short-term memory, a long-term memory, and ways to interact with the world. A computer is very similar. The most crucial piece of hardware is the CPU, or Central Processing Unit. This is the brain of the computer. It's responsible for performing all the calculations, executing instructions, and making logical decisions. It's the powerhouse that does all the heavy thinking. Next up, we have RAM, which stands for Random Access Memory. RAM is the computer's short-term memory. It temporarily holds the data that the computer is actively working on. For example, when you open a web browser, that application is loaded into RAM so the CPU can access it quickly. The more RAM you have, the more things your computer can do at once without slowing down. It's the key to smooth multitasking. So, if your computer ever feels sluggish when you have many tabs open, it's often a sign that you're running out of RAM. But where does your data go when you turn the computer off? That's where storage comes in. Unlike RAM, which is volatile and loses its data when the power is off, storage is permanent. This is where your operating system, your software, your photos, and all your documents are saved for the long term. There are two main types: traditional hard disk drives, or HDDs, which use spinning platters, and the newer, much faster solid-state drives, or SSDs, which use flash memory. Of course, a computer needs a way to get information from you and give it back. That's where input and output devices come into play. Input devices are how you send data into the computer. Your keyboard, mouse, microphone, and webcam are all perfect examples of input devices. You type a command, click a button, or speak into a mic, and you're providing input. Output devices, on the other hand, are how the computer shows you the results. The most common output devices are your monitor, which displays visuals, your speakers, which produce sound, and your printer, which creates physical copies. These devices complete the input-process-output loop by presenting the processed information back to you. So we have the physical body of the computer, the hardware. But a body without a mind is just an empty shell. That's where software comes in. Software is the set of instructions that tells the hardware what to do. It's the ghost in the machine, the intelligence that brings the physical components to life. There are two main categories of software that you need to know about. The first category is system software. This is the foundational software that manages all the computer's hardware and provides the platform for everything else to run. The most famous examples of system software are operating systems like Microsoft Windows, Apple's Mac OS, and the open-source Linux. Without an operating system, your computer would just be a very expensive paperweight. It's the conductor of the entire orchestra, making sure the CPU, RAM, storage, and all other peripherals work together harmoniously. It's the manager of the whole operation. The second category is application software, or what most of us just call apps. These are the programs designed to help you, the user, perform specific tasks. Think about the software you use every day: your web browser for surfing the internet, a text editor for writing code, a video game for entertainment, or the apps on your smartphone. Each of these is a piece of application software built to serve a particular purpose. They run on top of the system software, relying on the operating system to handle the low-level interactions with the hardware. So you have system software managing the machine and application software helping you get things done. Now for the most important part. How do hardware and software work together? This synergy is what makes a computer so powerful. Let's walk through a simple, everyday example. Imagine you're writing an email. You press the letter H on your keyboard. That keyboard is an input device, and it sends an electronic signal to the computer. The CPU, the brain, receives this signal. It processes the information, understanding that you've pressed the HE. The software, in this case your email application and the operating system, has instructions for what to do next. The CPU follows these instructions, telling the system to display the letter H on the screen. To do this, it needs to access the font data and send the right pixels to the monitor. While this is happening, the character H is temporarily stored in RAM, the short-term memory, as part of the email you're composing. Finally, the monitor, an output device, displays the letter H exactly where your cursor is. All of this happens in a fraction of a second. It's a beautiful, intricate dance between the physical hardware components and the instructional software code. Hardware without software is a body with no brain. Software without hardware is a brain with no body. You absolutely need both. So why is all of this so critical for you, an aspiring software engineer? You might be thinking, I just want to write code. Why do I need to know about CPUs and RAM? The answer is simple. Great programmers don't just write code. They understand the machine that runs it. Knowing how a computer works at this fundamental level is what separates a good programmer from a great one. When you understand the relationship between hardware and software, you can write more efficient code. You'll know why a certain algorithm might be slow because it's using too much memory, or how to optimize a program to better utilize the CPU when bugs and errors appear. And they always do. Your knowledge of the underlying system will give you a massive advantage in debugging. You'll be able to reason about what is happening under the hood instead of just guessing. Ultimately, this understanding allows you to build more robust, performant, and reliable real-world applications. You're not just throwing instructions into a black box. You're engineering a solution with a deep appreciation for the machine you're commanding. This knowledge is your superpower as a software engineer. And that wraps up our deep dive into how computers work. We've unpacked the input-process-output cycle, explored the key hardware components, distinguished between system and application software, and seen how they all come together to make magic happen. I hope computers feel a little less like a mysterious black box now. In our next episode, we're going to get even more fundamental and explore how computers actually understand data using the binary system of ones and zeros. If you're serious about building your IT skills from the ground up, make sure you subscribe and hit that notification bell so you don't miss the next step in our journey together. Thanks for watching, and I'll see you in the next one.